Thanks, Kishore, and thanks, Robin. Thanks, Kamal Das and IBM research team for taking up this. This is Pati from PALS Champion. Thanks for the colleges and then students and faculty who are participating on the second day. I welcome all of you for the second day session. Just an introduction. IBM Research is leading global organization dedicated to advancing science and technology established in 1945. It operates across multiple global locations, focusing on innovation, artificial intelligence, and quantum computing, cloud computing, etc. So we are working with PALS and IBM is having a long-standing relationship, and then we have conducted some one more session in last September. This is a second series of session. We are having, as you know, skill build portal also we have brought for you people, and then you guys are registering for doing online courses where you will be getting IBM batches, certificate, etc. So this is just to have some more interaction with you directly from IBM. We have arranged for these sessions. So these sessions, as you know, it is 4 day session, and then today it is second day. So first day we Deepak taught us about generative AI, what is that, and then uh, what we can do with generative AI, etc. Today, the generative AI is working on an LLM model. The LLM model for IBM is Granite. So today we are having Mehant, who is going to teach us how to install that one in the laptop and how we'll be able to use uh, some technique uh, to Ollama for interfacing hands-on with different prompting techniques such as chain of thought, zero, and few short prompting and few others. That is what he is going to teach us. So just an introduction about Mehant. Mehant Kamakomati is a research software engineer from IBM Research, and is building a research engineer and working on tuning customization platform at IBM Research India. In the past, he worked in CNCF, conveyor, move to cube, and AI4 code, especially for domain-specific languages. I welcome Mahant, and over to you, Mahant, and then please take it forward. I am once again welcoming all of you. Thanks.
Thank you, Pati, for the introduction. So I'll start with the session now. First, let me share my screen. Um, just confirming, is my screen visible?
Yes, sir.
Okay, okay,
You can, yeah, fine.
okay. So today we'll be looking at one of the series of models from IBM with state-of-the-art capabilities in multiple benchmarks. That is Granite, and how can we leverage that on a laptop and serve with a stack called Ollama. So before we dive into some hands-on, we'll also have some quick recap on some fundamentals behind Granite, right? So the original, let's have a quick look on the original transformer architecture. So this original transformer architecture has been proposed in this paper, Attention is All You Need. So this comes with two important blocks, the encoder and the decoder. So each of the blocks have a specific purpose. So encoder generates the latent representation of your text, and then the decoder essentially helps in generating the next token or a series of tokens for completion. So the main part of this particular architecture, uh, which has gone into use into most of the state-of-the-art models that you see today, and also the Granite, is the core of most of the models is the self-attention mechanism. Self-attention mechanism essentially has solved the problem of relating different tokens with other tokens within the text, and with the help of positional embeddings encoding, it would also provide the positional features or positional information of each token. So this has solved that particular problem of understanding, finding relation between various tokens within a text, and providing much more richer understanding of your language. So I won't go into depth of this. It's just a quick recap on this architecture. Um, so yeah, so this transformer started off as a encoder decoder only architecture, and then slowly took out different forms. These are the forms it took up. So the most widely used architecture type is the decoder only architecture. So in the decoder only architecture, if we just go back and see, so there are multiple components which are common between this encoder and decoder block. So if you look at here, the multi-head attention with layer norm with feedforward network, you see this particular block which is common in the decoder architecture as well, in the decoder block as well. So the decoder only architecture actually picks up only this piece of block and gets rid of the encoder part, and it has been widely used in many models like Granite and Llama, etc. So the other form or the type of the transformer architecture is the encoder only. So where the only the encoder portion of the transformer architecture is used, and some modifications. Of course, all of these architectures will have certain set of modifications on top of the original architecture. Um, in the encoder, the idea is to get the embeddings of your input, and there are many models like Granite embedding and also Robota, etc. In the encoder decoder, which is the original architecture, we have many models in that format of transformer as well, like BART. So you can have a look at it. So today we'll be looking at the IBM's series of class of models, which are majorly decoder only. This is basically the Granite architecture, and we have models of different sizes. And also we'll be looking at another advanced architecture which goes on top of the decoder architecture, which is essentially the MOE, mixture of experts. We'll also look at that in the later slides. So yeah, so Ollama, I'll give a very quick uh, introduction to Ollama. So Ollama is a lightweight serving tool which you can easily download. We look at it how to download etc. stuff in the later slides, but essentially it will also host the models as a repository. So you can, if you just get hold of the IDs, you can pull those models and use them for your local inference. So you can give prompts to the models locally on your laptop and then get responses, etc. And you can do more advanced use cases. We'll also cover that quickly in a slide in the later session. So Granite, as I said, uh, is provided in different set of sizes. So we have the smallest starting from 2 billion. You can find that particular size from Ollama as well, till the 34 billion parameters smaller, which is also available on the Ollama. So, like I said before, we have Granite MOE models. MOE is essentially a specific architecture which goes on top of your decoder architecture, and I'll be giving a very quick brief information about the MOE layer here. So if you look at here, essentially each MOE layer consists of multiple components here, like you see here, the gating network and multiple experts. So each expert can be a feed-forward neural network, or maybe stacking of multiple layers or a single layer. And then each of these expert is are basically kind of used in an ensemble fashion, where the gating network chooses which particular expert to be activated for the flow of information for a particular token. So this kind of architecture actually helps to have different set of neural networks to capture different nuances in the data that you are working on. For instance, if you're working on let's say language data, one of those experts might be good enough in certain um, characteristics of the data. For instance, let's say vaguely speaking here, but certain characteristics such as translation, some of those experts could be very good at it, so they get activated by the gating network. Or if you're working on some other use case, maybe let's say the um, uh, maybe simple text completion, so there some of these experts get activated. So Training of these MOE models is an other huge topic, but usually these experts with learning the characteristics of the data in your pre-training phase. These experts, the gating network understands which experts to activate, and also which experts take up is specialized in which sort of problem characteristics that we have in our hand when while passing it to the model. So, like I said, MOE layer, it's a layer, so you can add it to your existing decoder architecture. So, for instance, you can replace this feed forward layer in your decoder block with the MOE layer. You can do this. So, and then keep everything same. So, similarly, Granite also, like I said before, has MOE flavor of models, which you can try through Ollama. So these are the models I was talking about, the Granite 3 MOE and Granite 3.1 MOE. So 3.1 is more of an advanced version, so you can prefer 3.1 MOE and play with it. So yeah, it's a very simple search query. If you look at this page, you essentially can find all the Granite based flavored models and different model sizes. Okay, so installing Ollama, you can just visit this web page, and you can download it to your OS. Based on your OS, you can just download it to your laptop, and then you can open the executable, which is a pretty much a set of straightforward um, actions that you need to take, and then you can go ahead and install the CLI locally. So I have downloaded it locally already, so that for that reason I'm skipping this step. But the instructions are pretty straightforward once you go into this particular link. I'll just flash this link once. Okay, I think I'll skip that point. Okay, so so once you have the Ollama CLI locally, you can run Ollama help to actually know all the commands. I can just quickly show. So Ollama provides a lot of subcommands here. Serve is to start an Ollama server. So essentially, all these models have to be served to you by a inference engine. So if you want your inference engine to run, you need to have it running in the background. So for that, you can simply run Ollama serve, and your inference engine is started. And you can see the server also, um, exposes a lot of API endpoints. So because there's an API server as an offering in Ollama, it has opened up a lot of other possibilities, like integrating it with other front-end applications and agentic frameworks, etc. Which I'll just show you. There are a lot of open source famous libraries that you can play along with Ollama for your local laptop use. And there are other certain commands where you can see, let's say, Ollama list would show you what are the locally available models. For instance, I've local for this session, I've installed Granite 3.1 dense 2 billion parameter model, which is of size 1.6 billion, sorry, 1.6 gigabytes. I've downloaded pre because the models can tend to become a bit large, and yeah, it might take some time for you to download. And then you can do other commands, like you can do Ollama pull, to pull a particular model. Just give the ID and then it pulls that particular model. If your model already exists, it just does that. Or if the model has an update, it basically updates your local model with that updated version as well. So all these are like some sub commands you can play with to manage models locally on your laptop, and also start a server. And the most important point is essentially how you can chat with it, right? So you can also chat with the Ollama, which I'll be showing it in the later slides. So let's look at the next slide. Okay, so let me just run this particular model. So Ollama run is basically the subcommand you can use in order to start a CLI front end session which connects to the already pre-existing API server. So you can just simply run this. So Ollama run, and you can give the model ID, as simple as that, and then you are now have a interactive CLI session where you can type whatever you want, and the model should be able to give you the answer. So yeah, right here. So basically, this high has gone into gone into making a API request payload to your locally listening Ollama server, and then it essentially um, generates this particular output. So if you look at here, the good thing about Ollama serve is essentially it also spits out a lot of logs that you can look at if you are interested in what's going on behind the scenes. It gives all this information, what different special tokens are being used while being generated, what model is being used, what is the size of the model, so number of parameters in the model, which is 2.5 billion parameters, etc. So all this metadata, if you're interested, you can look at it while running your I mean, while maybe making an inference here. So hello, you can make another inference, and then that can show more information. So you can do that. uh, okay. Okay, so let's jump directly into some of the prompting techniques which exist in our literature currently. So I'll be covering all most of the prominent and fundamental prompting techniques here, but the space is growing, and there are a lot of state of the art papers coming up with different prompting techniques and multi agent systems and multi systems in collaborating with each other, and function calling, tool calling, so a lot of features. But I'll be covering up the basic and fundamental, most important, which are quite useful as well, and we'll look at it. So the first prompting technique is zero shot prompting. So the word itself says it's a zero shot. Essentially, you won't be giving any example to your prompt for the model to understand, like give a pair of question and answer example, and then you ask a question, right? So you don't do that directly. You ask the question, whatever the question you have. So that's essentially the zero shot prompting. So where we don't really include any sort of reference examples. So for instance, if your question is this, a equal to 10 and b is 20, so what would be a plus b? So you can do that here. So Ollama has multiple subcommands before I show that in running on Ollama. So let me show you one more nice feature about Ollama. So when you do this, it would also give different options you can play with on your interactive session. So for instance, you can set some session variables and use it as part of your prompt. You can also show, like slash show will show what current model you're essentially using. Load, you can on your interactive session, without closing that session, you can live load a different model if you want, and then you can save your session as well, and then you can clear as well. So all these inferences are contextualized. So what I mean by contextualized, your previously made prompts and answers are also picked up while you're making your uh, current prompt as well. So for instance, if I do a prompt here, that would consider the previous chat history as well. So if you don't really want that to happen, you can just do slash clear, and that would clear the session context. So I would prefer doing the slash clear, because I'll show each of these examples, because we want to do zero shot prompting. So we really don't want to pass anything to the context. So let me clear the session, and I'll show you this particular example. Okay, so right here, if you see, I just didn't give any examples here, and then you can see that model kind of gave a reason, gave steps of addition, so like decent, and then you have the final answer as 30. Okay, so you can play with other examples as well, and yeah, and mostly the serving part is pretty much lightweight and should be accessible. So the next technique is the few shot prompting. We also call it in context learning. So context is essentially, like I said, you're basically giving some pre-information to your prompt, so that the model understands what you're exactly asking. So you are giving some examples in your context so that the model learns from those examples and then answers your question. So in few shot prompting, you can give as many shots as you want, as many examples you want, it's pretty much straightforward here. You can give relevant examples and then ask a question here. So this is one interesting use of few shot prompting. So if you see here, the dollar operator has no real meaning uh, in the parametric memory of the model. For instance, a dollar b is not that something model might have learned while training, but we want to introduce this special operator, and I induce that special meaning to it, which is very much subjective here. So my meaning is that a dollar b should happen, should perform a multiplication between a and b. So if I want such a special meaning which the model might have not seen in the training, I can add some of these examples and let the model learn from the patterns of the examples and then answer my question. So let's try out this example. Okay, let me clear it. So yeah, it seems to figure out the multiplication as the operator being happening, is something being expected here, and it does some math operation, gives a number. And the most interesting part is it also gives out the reason that from the pattern it understands that this kind of multiplication happening between a and b. So these are some interesting things that you can play with and kind of see how the models work, and probably have your own use case where few short prompting might help. So you can have that here. Okay, so let's look at this wonderful insight on multiple short prompting, multiple techniques of short prompting. So if you look at here, we have three techniques covered in this: the zero shot prompting, one shot prompting, and few shot prompting. One shot prompting is pretty straightforward. You're using one example in your context. Few shot prompting is more than one example. For this plot, they have used three examples as a few shot. So if you look at here, some of the interesting patterns to understand. The x-axis is essentially the size of the model in terms of the number of parameters, and which is increasing from left to right. And the y-axis is essentially the accuracy. So this plot has been part of one of the analysis papers here. You can look at it offline if you are interested in other sort of analysis done in this paper. But this is one of the interesting plots where they have executed these prompting techniques on different sized models and on different benchmarks, and they found an aggregate of all the, basically average of all the benchmark accuracies, and they plotted. This is mostly like a summary of this plot. So if you see here, the first thing that you would obviously notice is that the zero shot prompting is always kind of um, uh, um, uh, 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 inferior in performance compared to the others, and the performance kept increasing based on the number of examples that you provide in your context. Second thing is the difference in this performance also kept increasing as with the increase in the model size. For instance, the difference between the different short techniques is not that significant. However, the difference turned out to be significant as you go on different big sized models. So yeah, let's go to one more prompting technique, which is called as chain of thought prompting. So chain of thought prompting is pretty straightforward prompting. Essentially, the what you do is you ask the model. So you ask the model to reason before you answer. So let me give one quick example. If you look at here, the previous example, though we didn't ask the model to reason out, the models were already trained in a good in a chat based plus reasoning, essentially chat based in a particular data where generate the reason first and then essentially provide the answer. So you see that it provides some reasoning, or it's thinking on why it had to think that the dollar sign is essentially multiplication. So it's kind of thing that it has mentioned in this particular line. So essentially not all models can do this. When At the time this chain of thought prompting was proposed in a paper, the models were quite inferior, and they couldn't generate the reason by themselves. So what they did is a very simple approach. They basically add uh, so, uh, ap- ap- essentially either append or prepend a set of tokens to your question, so that uh, the model knows your intent, that it has to reason first and then answer. So not all of these texts would may not work. So this is more like an empirical thing, that you might need to find which text would mm, navigate the model so that it always reasons first and then gives the answer. So that's the crux of chain of thought. It's pretty simple technique. You just need to ask it while answering. There's another format of chain of thought reasoning, which was also proposed in the same paper, but they felt it's not needed. uh, Essentially, if you look at the few shot prompting, so here you can give examples in such a way that you give the answer. So here the answer is directly given as 200. Rather, you can have answer to include reason as well. So you give a reason and then give the answer as 200. What does that do is it will make the model follow that particular format. So when it generates the output without you asking explicitly, from implicit understanding of your examples, it generates the reason first and generates the output. The But of course, as the model size increases, they thought that as an emerging behavior, you don't really need to give any examples. Just directly ask it and it should be able to answer. So this is the crux behind COT. So let's try this out quickly on our. Okay. So since we asked it to reason this particular question, so I went to the market and bought 10 apples. I gave 2 apples to the neighbor and 2 apples to the repairman, and then went and bought five more apples and ate one. So essentially, how many apples I'm left with? So it's essentially simply um, uh, t- t- 10 minus 4 plus 6, because you have 5 more apples and you eat one apple. So it's just 10. So the answer is correct. But usually the models used to just give this answer 10 directly, or they would have given really bad answers, since they couldn't calculate from this particular or calculate, or maybe basically calculate from the question. So to overcome that problem, you ask it to reason first, and now it has generated a very good step-by-step reasoning. So it went from, you start with 10, and then you subtract 2, and then you subtract 2 and you add 5. So and then you subtract 1 because you ate 1. So this kind of reasoning actually helps reinforce the model's output, and then actually improve its answer. So we'll look at a plot on that in the next slide, but this is how it works. Okay, so here's the plot. So if you look at here, the plot is again taken from paper. It's a very good analysis paper, where they provide the performance difference between chain of thought prompting and zero shot prompting. So again, a pretty straightforward plot here. The x-axis, the model size keep increasing, and on the y-axis, it's essentially the accuracy. So if you look at here, for smaller models, the zero shot prompting and the chain of thought prompting has shown similar performance on an average. But for bigger models, the chain of thought prompting actually kind of surpassed with a very huge margin than the zero shot prompting. So this actually shows that as the model becomes bigger, it has some emerging behavior where it was able to, generating reason for itself was able to improve its answer and give a correct answer, right? So this trend was is pretty much interesting. And one more thing you might have noticed is, it's pretty simple. The difference between these two prompts is very simple. In zero shot, you give one question, but in zero shot COT, you give a question and prepend or append it with asking explicitly the model to reason first. So it's a pretty straightforward prompting techniques, but with a lot huge gains in bigger models. So let's go to another technique called retrieval augmented generation. So retrieval augmented generation, by its name, essentially you retrieve some information, uh, you populate some sort of information based on the user's query, and then you add that, you use that as your context, which will be prepended, or mostly in most cases it's prepended to your prompt, and then it's sent to the model so that the model's answers are contextualized to that particular contextualized to that particular uh, 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 information that the user is looking for. So if you look at this pipeline, this is a very standard act pipeline. Um, the user provides the prompt, uh, uh, and then essentially based on the prompt you kind of have a huge corpus of information data. Now what you're trying to do is, from the prompt you want to actually identify candidate documents which are quite relevant, or maybe very much similar to what the prompt is expecting for, semantically similar. So you try to extract those documents, and then you prepare a text out of it, and then you prepend it to your prompt, and then you would prompt the model with that. So that in that way, essentially your answers are more contextualized. So this is the whole process. There are a lot of variants on this RAG pipeline. This is the simplest format that you can mostly look at, but there are huge variants, and there are a lot of optimization happening in the retrieval side as well. How can you retrieve, how can you better retrieve good candidates of documents, etc. I'll go to this slide first. So here's one good example that you can try. So here, let's say the context yellow part is essentially the consider it as a document retrieved based on the user's query. So this document is retrieved from one library's documentation. So this basically describes a couple of things here, essentially which parameters can be used, right? So max grad norm, what is the data type of it, and then the information about what max grad norm does. It does gradient clipping, etc. And then what is max steps and the meaning of the max steps, and then etc stuff. So this you have retrieved, you're passing it as context. Now you're asking which argument is to be used to do warm up. So if you want to do warm up, which argument has to be used? So from this context, or from this available set of arguments, you want the model to choose the one that you can use it in your code. So that case, we expect the model to generate warm up ratio, right? So let's give it a try. So let's start with um, a simple prompt with no context at all, and we would of course expect uh, we would of course expect not the answer that we're not looking for, because there are a lot of libraries, and different libraries can have different understanding of what warm up is. So the model can give literally anything. So the answer is not grounded to the user's intent or what he's looking for, he or she is looking for. So let's give this. So essentially if you look at here, it gave you a piece of code where you can use warm up, and then it went with the warm up steps as an answer to the argument that you can use. And essentially it also gave an example, and then it mentioned warm up is essentially what warm up is, right? But this is not what I'm looking for, right? So if I'm looking for one option out of these available options, and I'm looking for warm up ratio. So now we'll ground it. We'll see if the model grounds its response to the context here. Okay, so the argument that is to be used to perform warm is the warm up ratio. So it actually got it right. So it was able to pick up the right argument. So this is one of the use cases of RAG based prompting, where if you want to ground your prompt to a particular document or some information, you can basically do this. Uh, and maybe not all formats may work. So there could be a lot of prompt engineering, or you need to lot of manual prompt engineering that you might need to do to find the right format you can use so that the model performs consistently well for all the user queries. So that's a different field of work that you need to do in order to find the right format, etc. so that the model constantly works well. So okay, so going forward, with Ollama, you can have a lot of integration. So as I said, Ollama, when you do Ollama serve right here, it exposes an API at this endpoint, and it exposes a lot of endpoints as well. Like uh, I'll give a quick look here. Yeah, so it gives a lot of stuff here, like for instance, embeddings, create, push, copy, delete. So whatever you are able to do on the CLI, you can actually do directly query the API server and then get things done. So since the Ollama has an API based serving, um, you can actually integrate a lot of other tools. So I would uh, maybe ask to use this and maybe use one of these probably locally and try it out. So it's very simple. When you download this one of these projects that widely used and have good number of stars as well, so you can use this and then provide your API link to it. You do an Ollama serve to serve the server, and then you download one of these CLI tools, and now you can use the CLI tools on top of Ollama. So Ollama acts like a model serving and inference engine, whereas the other of these front-end user-facing applications can work along with Ollama. So they're very easy integrations you can play with, and you can also have a very good setup on your local for different use cases. That's all I have for this session.
Mr. Mahan, till now, shall we ask students if they have any one or two doubts through chat box, if they
Sure.
understood? Because Kishore, you can enable chat box.
Okay, I'll enable the chat box.
Yes, participants, you can ask your questions through chat box is enabled now. So he has explained the step-by-step process very clearly. So any doubts or one or two questions you can raise. If you want to ask orally, we can unmute also if you raise your hand. No questions. Any questions received? Yeah, one question has come. Yeah, I will write out. Mr. Mahant, the question, I am reading it quickly.
Yes.
How, this is Dr. J. Felicia from TCE, how Ollama can be used for research-related paraphrasing? How far it will be yield better results?
Right. So Ollama is, as I said, it's just a model serving an inference engine. So it depends on the model that you're using underneath. So Ollama registry, if you look at their website, have a huge number of models. So you can try which model works well for your paraphrasing use case.
Okay.
You can give Granite
So
a
this,
as well. Yes.
okay. Yeah,
Also,
the
we
next,
have few questions.
yeah, go ahead, Kishore.
What are the career options after learning Gen AI? It's based not
That is
about.
a general question.
Okay, just another question. Can we create LLMS as tired? Just a second.
No, see,
But
can we create LLMS as he tried, but it's asked for money tokens?
Uh, I, I I didn't get the question right. Money
Yeah,
tokens.
see, what he is asking is, can we create LLMs? Actually, he was trying to create his own LLMs. That is his meaning, I think. But
Okay.
it's asking for money tokens, he is saying.
Money token. Uh, Creating your own language model, I would say it's an expensive process. I mean, it has pipeline of huge pipeline of processes involved, data handling, data retraining, fine tuning, etc. Is a huge process. Um, yeah, so it's a huge process. So I didn't get the term money tokens here, but I would say it's a huge process. And if I'm in your shoes, I would start with an existing model. Solve
Okay.
it. Yes, yes.
Yeah. One more is, can you give some few relative examples on RAG for engineering?
Mm, I can maybe share paper use case paper on RAG, but for engineering, uh, um, I mean, from a use case, how would you use how would you? I mean, I the exact question: how would you use RAG in a engineering domain, or I mean, is it like how do you engineer RAG? What was that part of the question? I
Yeah,
couldn't.
that is also the question is not clear.
Yeah.
And other question is, can you explain briefly about zero-shot prompting over models?
Okay. I think I covered the zero shot prompting
Yeah, you
most.
have covered already, but I think they want to know in detail.
Okay.
If you have a time, you can take it in the last.
Yeah, sure, sure. Yeah.
And one more thing, how can we efficiently apply RAG in healthcare?
Well, so if you look at it right, everything boils down to set of characters. So RAG is meant to retrieve the relevant documents meant for your user query. So in healthcare, if you have a, let's say for example, a chatbot to maybe prescribe medicines. Now you want to actually for the user query, you might want to do, let's say, a semantic search between your symptoms with the medicine descriptions. uh, and then you can basically, Dolo has, let's say, paracetamol, and it can do cold, etc. You can have some features for that paracetamol. You can retrieve in that way and then use it as your context and maybe recommend. So I think it's kind of very little to do with the domain, but more to how would you use it. And it boils down to text, right? So yeah, say that.
Okay, the next one is, are the Granite models accessible via Ollama and LM Studio, or Hugging Face the same? Why do the
Yes.
model sizes change if the number of parameter remain the same?
Okay. So first question is hugging. Sorry. Let me. What was the?
Ollama.
Yeah. So the models available on Ollama and Hugging Face are same, but it's just we keep updating the model weights, so you might find different versions and may not be synced between both of these repositories. But both serve the authentic Granite models. You can use them. That's the first question, right? Different size. What was the other question? I was trying to actually find it on the chat.
Okay. And
So there's a
Kishore,
question.
you can disable chat box now. So we have many questions. How can we leverage Ollama to deploy LLMs on Android locally? Any client apps or APIs, you know?
Okay, so if Olama, as far as I know, you may not be able to deploy it or deploy it to serve on your Android app, Android phone, but you can have essentially, if you have Olama serving on your, let's say, um, on your laptop or any kind of server, right? Even uh, server with very less compute, you can essentially aggress that particular address, so that you can maybe serve it out, and then you can connect your Android app from there. You can do a simple client server communication there.
Okay. Final question, then we'll take it last to the other questions. How could chain of thought affect the time taken for output?
uh, okay, so chain of thought essentially, yes, it depends on the number of tokens the model would generate for the reason. So if the reason is really big, the time for inference would scale with that. So if you look at the recent models, the reasoning models, right? So if you ask them to reason, they actually generate huge tokens of reasons. So it is just directly proportional to the amount of number of reason tokens that it generates before the answer.
Okay. Yes, you can carry on.
Robin, I'm done with the session. I've completed my
Oh,
session slides. Yes, yes, yeah,
you have
yeah,
done with the session.
yes, yes.
Okay, now you can. Shall we go for the Slido quiz, or we'll take some other questions? Yes, I'll finish one or two questions
Okay.
because I am just skipped that. How to improve Ollama's performance?
Performance, sorry. So there are a lot of system performance, or the model performance itself isn't clear, but let me answer one by one, right? So on the system performance, Ollama is meant for a single user, single thread serving. So it's more like a personal use. You can't serve it and maybe distribute it to hundreds of users to use it on the same server, right? So it will be very slow in that case. So Ollama is meant for the personal use. There are other inference engines which are very much powerful, like VLLM, which you can deploy locally and you can scale to thousands and millions of users based on your system compute. That's the system performance. On the model performance, again, you can improve by based on multiple techniques. As I said, you can use COT prompting, you can use RAG, you can use few shot prompting, etc. But which works well, you just need to give a manual trying. We also term it as manual prompt engineering. So you need to try it for your own use case. And second thing is, you can fine tune your model, convert it to Ollama compatible model, which is pretty much straightforward. You'll find documentation on it, and then you can serve it with Ollama and use it. So that's another way of solving it. Yes.
Okay. Next question. I want to create for a specific topic with the less answering. Is it possible? And if yes, how?
Less answering.
Yeah, less answering. I don't know whether he's talking about the less prompt he's saying.
Okay. Okay. So this is also a field in prompt engineering. It's very straightforward, right? So one way is you essentially ask the model to just generate the answer. Don't give me any reason. Don't generate any extra tokens. Just give me the answer. That's one way. Second way is give few short examples to it. Give examples to it with just the answer in the examples. The model will learn that pattern and then it will generate the short possible answer for which matches the few short example pattern that you have given. So these are the quite two like inexpensive ways that you can do apart from fine tuning, instruction fine tuning. Yes.
Okay. So next one is how COT, that is chain of thought, can enhance interoperability in AI decision making.
AI decision making. Okay, the AI decision making is pretty much. I'm not able to understand what is meant by AI decision making, but let me give you an example, right? So if you are using it in an agentic framework where multiple models wanted to interact with each other, so the COT might not help in giving any information to the other agent, but it
Hmm.
might help the same model to generate the right answer. The answer might be, let's say, a better function call or an agent call, so that it chooses the right agent to call or something like that. But the COT reason, the reason itself might not be helpful for the other agent or any other system per se. It's only just to help the model to reinforce on its own answer, reiterate on its own answer, and then answer it right. So, yeah, I,
Okay. Yeah, go.
I'm not sure if that was the question, but that's what I understood from
Okay,
AI.
fine.
Yeah.
Okay, next one is how can we train RAG, that is RAG, to answer controversial questions like facts versus
Facts versus
opinion?
opinion. Uh,
Opinion, yeah.
okay, so okay, so RAG systems have developed a lot of techniques involved, but the most basic one is what you do is essentially you train an embedding model. So what you want to do is, if you see it in a very simple way, right, what you want to do is you have a user query and you have a lot of information. Let's say you have a lot of facts, okay, and now you have one bucket full of facts, one bucket full of opinions, right? So let's consider this use case, right? Now you, for the user query, you want to find let's say the most relevant facts that can go as context into this. So the basic most vanilla based RAG system could be you train an embedding model which generates the latent representation of your text user query, and also you gets the latent representation of all the examples in the facts bucket and also your opinions bucket. Now you can maybe do a semantic similarity. You can do a very simple semantic similarity and find the most top k candidate documents which have highest similarity score. You can retrieve them. K could be an hyperparameter here. You can retrieve them and pass them as context, and then you can have the model to generate. But next is, if your question is on the opinion or bias, right? That is more to do on the inference side that you might need to control. They're tooling like guardrails, etc., where you can maybe control, you can generate the answer, but then you control specific set of text or tokens not to be omitted at outputted at all. So such kind of thing can be done.
Okay. Yes. So participants, we will move into the Slido quiz. Then we will come back for the question and questions. So you can write your questions to the mail ID which is posted, that Kishore has already posted in the chat box. So please write the mail if you have any questions. Yeah, he's posting it now. And Kishore, please post the Slido link also. Many of them have already joined. So I will share my screen and we'll start the Slido now. I think my screen is visible.
Participants can move to their web screen, not in the Zoom screen. You have to attend the Slido quiz in your web screen.
Just a little bit.
I think. So I think you have network issues, sir.
Yes, yes. I am just.
Can I share my screen?
Yes, go ahead.
Can you stop sharing?
Yeah, I'll stop sharing. Now it's coming.
Okay, then it's fine.
Oh, if you suppose in between, if I get any network.
Okay.
Okay. I think,
I'll share my screen. Just a second.
And you are running it?
No, I already have. Please, you can see my screen, sir.
Yes, but not Slido. Yeah, fine.
Okay, can I start?
Fine, good. Yes, yes.
The first question.
Participants, please see your browser and answer it in the browser, not in the Zoom screen.
Okay.
So your first question, which of the components of original transformer architecture does Granite use? You have three options. Encoder only, both encoder and decoder only. You have 25 seconds. That is 47% answered B. Check.
Okay. Just,
Oh, the answer is C, so 22%. Yes.
okay, be
next
ready. I'm
one.
going to the second question.
Okay. So what is a in MOE, feed power neural network, convolutional neural network, activation function, and layer norm.
We'll see the answer.
So,
Okay.
yeah, 65% answer correct. Yes, go ahead, Kishore.
Okay, third question. Does Granite offer MOE classes of models? There are two options, yes or no. Okay. 89% of participants have answered 89%. Okay, let's see the correct. Okay, 89% of the participants got the correct answer. We'll move to the fourth question. Which of them are part of a typical MOE layer? Expert layer, gating layer, all of them. Okay, 80% of them answered all of them. Okay, 80% of the participants got the right answer. We'll move to the fifth question. How many examples do we give to the model in zero shot setting? After this question, we will have a leaderboard. Okay, 73% answered zero. Okay, 73% got right. In the end of 5 questions, Jashwant Raj is in the first place. I don't know which college you are from. Akash, Srijit, I know EEC Ishwari. Praveen H has got the fourth place. Anbarasi as fifth place. Okay, we move into this sixth question. Is performance of in context learning independent of the size of the model, number of parameters, and number of examples used? Okay, it's almost all. Okay. The seventh question. Does performance of model while using COT is most cases improve with increase in model size, number of parameters? Okay, 94% answered yes. Okay, it's the correct answer. Okay, eighth question. Which technique is closer to signaling to the model of generate a reason before answering? We have four options: few shot prompting, chain of thought, single shot prompting, zero shot prompting. Okay, You see the correct. Okay, 82% of the participant got the right answer. Ninth question. Can we use a encoder as part of finding relevant document related to the user query in a RAG pipeline? Okay, 86% of the participants got the correct answer. We move to the last question of the quiz. Does Ollama expose a REST API? After this, we will have the final leaderboard. Okay, 85%. We'll go for the leaderboard. Okay, Jashwant Raj, from which college? We don't know. He retained his first place. Anbarasi came from 5th place to 2nd place. Sahana in the 4th place. Siddharth is 4th place. Himani Chandra from Loyola College, 5th place. Congratulations. I'm stop sharing. Sir, over to you, sir.
Okay, thank you, Kishore. Yeah, participants, Kishore, you can enable the chat box and make the co-host of Ravi, Mr. Ravi, and Anu, Miss Anu. Both have joined. So, participants, you can ask question by raising your hand. We will unmute you, or you can type the questions in the chat box. Kishore, you make co-host of Anu.
Yes, I've made, sir.
Ravi.
Yep, I can hear now. Yep. Can you hear me?
Yeah.
Wait, thanks.
Yes, sir. Yeah, Ravi, sir, you can give concluding remarks and vote of thanks also.
Yeah.
And you can summary the entire session. And but before that, I will ask participants if they have any questions, more questions. Then I will call you for concluding remarks and vote of thanks. Ravi, sir.
Yeah, hello.
Yeah, very much.
Yeah, I can't hear you.
Okay, so
can you repeat what you said? Can you repeat what you said, Robin? Because I got a call in between.
No, you give a concluding remarks and vote of thanks after asking
sure.
questions.
Oh yeah, sure. Oh yeah, sure. No problem. Yeah.
Okay, fine. Because Mr. Patti has having some issues in the internet. I think he put the message. So.
Sir, there's a question. How can we implement Ollama in Azure?
In Azure platform.
Yeah.
Azure, I'm not aware of their offerings, but if they offer OpenShift or Kubernetes, which is a container orchestration system, then what you can do is you can deploy Ollama as a server there as a container running in the Kubernetes cluster. And then, of course, you can connect any CLI or a front-end app to that endpoint. So, yeah, that's. But I'm not sure about the other offerings of Azure.
Okay. So, any questions Kishore received in through mail in Ask Pals PMO?
No, sir. No, sir.
No questions. So, participants, we have an eminent resource person, and it's the latest technology. You can ask questions. Ravi sir, if you have any question, you can also ask the resource person, as you have watched the entire session. So,
I didn't watch the entire session, so you know.
There was a question. What are the key cards? You can read out, sir.
Pals PMO. Ambarasi.
Anbarasi from Lizard.
Wonderful.
What are the key
Anbarasi?
considerations for optimizing the performance of Granite model? Okay, when say serving them on a laptop using Ollama terminal interface. This is the question, sir.
Yeah, so model performance, you will find it at its best because by default Ollama does a chat interfacing. So chat interfacing essentially helps you. For instance, if you remember the first prompt I did, right, it was just hi, and we got a very good response from the model, which is very much like a human, I mean human responding to us. So it uses chat templating, and so most cases you would get you won't get a garbage response per se. But the other thing is, as I said, all the prompting techniques, right, together you can use from your terminal, you can from the CLI, and then you can see which one improves the performance for your particular use case. So yeah, that's it. And another one quick point to add is, if the smaller models are not doing not fitting for your use case, you can use the bigger models. We have models of size 8 billion, 34 billion as well, so they'll give much more better performance. Thank you.
Okay. Mr. Mahend, one more question from Neeraj Kumar Das. If Ollama were to integrate on-device fine-tuning capabilities for large language models, what challenges it would face in terms of hardware limitations and user accessibility?
So traditionally, fine tuning or training, right, in general, traditionally they are very slow on CPUs for decent sized models like 2 billion and plus. So that would be the biggest challenge, right? So if you have all the laptops are like more like a commodity hardware. So commodity hardware, they lack good compute, RAM, and also yeah, VRAM. Essentially, GPUs won't be available. So these are the biggest challenges from the hardware side, and the and and then the resulting problems would be a very low throughput, right? So the per step time would be very less. That you might need to wait for a lot of days for to even have a decent model out of your training pipeline. So these are the biggest challenge, and I think Ollama doesn't really work with fine tuning as of now. It only serves as a serving engine.
Okay, so next one, what methods from Ritika, what methods can be used to optimize inference speed for language models, sorry, large models?
Okay, so you can do, there's a concept called quantization. You can do that. So quantization is essentially, in a nutshell, is a lower precision representation of your model without losing much of its capabilities. So that could be one of the good ways to actually uh, uh, um, you know uh, optimize or improve your inference speed on a very large model. So you can do that. Quantization has multiple techniques. You can see that.
Okay. One more is from Dineshwaran. If I want to use large models, can I use any cloud-based services to train models?
Yes, from IBM we have Watson X. I would I would suggest you to directly, you can search for Watson X and see the capabilities there. You can train and you can do inferences, etc. And other cloud services, as far as I know, I'm not aware of. So so yeah, I can't comment on other stuff, but yeah, this is what I can recommend.
Okay. Okay. So next, Jagannathan P. Can Ollama be integrated with bioinformatics tools for AI-driven research?
Yes, so if you see it in a if you see it like this, right, Ollama is nothing but simply serving the large language model and giving a nice API interface. So if you give it a bunch of text, it would give back a bunch of text to you back. So if any system, any existing system, if you want to integrate, just build a REST client and then do an inference to the existing Ollama server. So that's how you can integrate. Literally, you can integrate anything because of that fact.
Okay. Next one is Harini from RE. Any limitation models available in Ollama compared to larger cloud providers?
Robin, your voice broke. I couldn't hear that question.
Yeah, see, are there any limitations to the models available in Ollama compared to larger cloud providers?
Okay, so in terms of the model, so uh, larger crowd. Okay, first point is I'm not aware of the large crowd providers, but if you look at on the Ollama, I don't see any limitations. You have different size models. You can inference on different size models. So if you have better compute, you can also run 34 billion locally. If you have a nice enough GPUs to use, you'll have decent inference speed. You can serve large models like that for billion as well. So it's more like a palette of options that you can choose from in Ollama as compared to the cloud services, right? And another important thing, as you brought in cloud, right? Ollama helps you to do on-premise inferencing so that all of your data stays with you. So whatever the inference you're doing, it stays with you and it doesn't go somewhere else, right? So these are also kind of a benefit that you get. Yeah. Thank you.
Many questions we are getting. Our name is Vishal VM. What are the key differences between supervised and unsupervised fine tuning for LLMs?
Right. So let's understand fine tuning, right? Fine tuning will always be supervised because essentially you give the model the labels it has to predict. um, so essentially you give a q and a pair, where you ask the model to generate tokens for the answer while attending to the question, and you only calculate loss for the answer tokens. So it's more like a supervised learning there. In terms of pre-training comes into this particular unsupervised learning, where you don't have qa pairs but you have a long running text. So you essentially ask the model to attend on, let's say, the first token, and then predict the very next token in that particular long running text, and you keep updating the weights during this process. So there's no question and answer pair, but more like unsupervised learning, where you're trying to learn just the next token given the previous tokens, and you continue. So that comes as the pre-training. You call it pre-training.
Okay, next
Robin
question
sir,
from
just a
Himani.
second.
What are
Just a second, Robin sir. Many questions regarding the online quiz. It is a live quiz. It can be monitored only once. We will share a final quiz, offline quiz at the end of the series. You can attend that. Okay. We can share the Slido quiz. Slido quiz is a live quiz. Okay. Okay, sir. Because
okay?
I
So
getting
next one is Himani. What sort of power consumption are we looking at to run such good performing models?
Is it power consumption?
Power consumption, or we are looking at? I think she's talking about some running GPU or something like that. The machine they are
Okay.
talking about.
uh,
So what kind of power is required for to run a huge models like that? That is the question.
I have no direct absolute metrics that I can talk about on the power consumption for huge models, but yeah. So I don't want to pass a comment there, but yeah.
Okay, fine. So next one is Pooja. What is the security model for interacting with Ollama's REST API in production environment?
Well, so Ollama, um, you can you need to build out from Ollama. Basically, you can have an reverse proxy like Nginx working on top of Ollama in order to bring your in order to build that secure deployment model. But like I said, Ollama is really not meant for the production, so it's more like a local serving engine. Even if you do it on premise, it's just meant to be used like one or two people. So it's not like you want to scale it to different people, a large number of people in production. There are other engines, like I mentioned before, like VLLM, which you can deploy, and which are like state of the art inferencing engines, and you can deploy for production use. Yes.
Next, the final question, I think, from Pratipika. Can Ollama be used for multi-model deployment? And how does it handle managing multiple models?
Well, so that's a good question. So Ollama, you can deploy multiple models. So when you do an Ollama run a particular, so basically there are multiple stages here. So you can download the model from the remote repository to the local repository, and when you do an Ollama list, so essentially it will list all the local model checkpoints. And then when you do an Ollama run of a particular model, it essentially runs that in the uh, Ollama server. The Ollama server loads that model into memory and then keeps it in memory and waits for the queries. So once a session is killed, the model is deallocated, and then you can repeat this process. So all of this is mostly, if you don't have a GPU, it is handled in the memory. And it's a single server doing all of this, because if you remember, I showed Ollama serve when I did. It was an interactive server session, and as in you do an Ollama run of a particular model, all that logs can show up there. So that can help you to actually see that what's really happening, how server is allocating and deallocating a model.
Okay, I think we are finishing with the questions. Mr. Ravi? Mr. Are you?
Yeah, 1 second.
Yes, you can go ahead. You are concluding.
Mhm. Yeah, can you hear me? And can you see me?
Yes, yes, very much.
Good. So shall I start now? All questions are over. Or is there any
Yes,
final
sir.
question? Last one question, last two question, anything? Because the session
Nothing, no
is
questions.
interesting and the questions are more interesting. That's why I thought I'll give a
Yes.
pass before I start. Anyway, I mean, thank you very much, Mehan,
Yes.
for a very, very insightful lecture from IBM R&D department. Of course, we all have a lot of respect for IBM. Now it has only gone up because IBM R&D is really wonderful. I attended the earlier lecture by Mr. Kirti something, right? I forgot the name. Yeah, he had done a wonderful job. It was very interesting. That's why I thought I'll attend this one also. I think both the sessions were, even though highly, I mean, technical, but very, very friendly and very easily understandable, because these are all highly technical thing, very difficult to sort of explain, But in spite of it, both yourself as well as Kirti, and both of you have done a great job. And it did generate so much amount of interest, right, in all the faculty and students. That's obvious from the various, I mean, questions which are being asked in this. My request to the students and faculty are, I think we have, I mean, one or two more lectures next week. I know that you guys are very, very busy with your examinations and a lot of other things, but please do not miss these two sessions because they are coming from IBM R&D division. You can never hope to get these sessions otherwise, because you can get from one of the IBM dealers, but getting it from IBM R&D is a great gift. And and Pals was able to convince them to come and give this lecture. Please don't miss any of the lectures. Also, you should go through the IBM's website, where there are a lot of other courses available related to this. Some of them are free, some of them are chargeable, but very reasonably priced. And well, based upon your interest, and you can attend some of the courses, and that will certainly give you a big chance for, I mean, getting a wonderful job in these exciting areas which are going to really grow. Because these are things which are normally not taught in the college, because college is always, I mean, they take their own sweet time to revise the syllabus and so on and so forth. So I don't think we should wait. Now that PALS has opened up the opportunity, you guys should approach, IBM, and you should learn as much as possible. And the whole world will be, in fact, I mean, your employment source. I mean, you will get a job in any part of the world with this kind of well, knowledge, right? I mean, it may not have to be IBM, but it could be some other equally good company. It could be AIGN, or it could be, I mean, Tesla, or it could be an Accenture. I don't know, but please don't and miss out the remaining two lectures. Ask questions also, and go through the website and try to and get educated more and become up to date in these exciting fields. Today being Friday, I know that all of you are waiting for the weekend. So I don't want to take any more of your time. Before that, I want to thank the pals, PMO, both Robin and the team for having done a wonderful job. I like to thank more the IBM team, R&D team. I know they're extremely busy. In spite of their very, very busy schedule, they could, take time off, which is, convenient to, our own faculty and students, and also had given outstanding lectures and gave us lots and lots of technical inputs. And I like the, faculty and students who have come for the lectures. I know that they are all very busy with various courses, all faculty, and doing all kind of things, evaluations and whatever. In spite of it, in fact, I see that the attendance was as much as 650 people today. I think it was slightly more lasting, but I was very happy to see the attendance of both the faculty and students. I was more happy to see now the faculty students asking questions. I remember, I think last year when we had the IBM session, one feedback from IBM was nobody was asking question. So this year, I think they'll say that they're asking too many questions. Anyway, wish you all a nice, happy weekend. Bye bye.
Thank you, Mr. V. So I repeat again. So the next session will be on 11th Tuesday. So the topic is prompt engineering. Miss Pooja and Miss Suranchana from IBM is taking the session. So please attend that session also. We will share and we'll put the message. I think many of them have joined the WhatsApp group invite. So we will share the details through WhatsApp also. So please don't forget to join on 11th March, sorry, 11th February. So that Kishore will be sending the video recording of today's session and feedback link also. So please, if not already watched today's session, so please the recording and give your feedback. So feedback is very important for us. So thank you. Kishore, you want to give any other inputs?
Okay.
Final
Feedback
comments?
compulsory to get the certificate. I'll share the today's feedback in the mail to the participants. So please give your feedback.
So certificate eligibility, so you should attend all the sessions with the attendance and the Slido quiz and feedback and overall quiz also we will share it at the end after 4 sessions. So the eligibility criteria is like that. So thank you. Thanks for joining today.
Robin, you don't have to worry at all with this kind of quality programs. I'm sure all the people will certainly attend all the 4.
Yes. Yes,
the
yes.
courses, right?
So it's our duty
So you don't have to
that.
do more selling at all on that. They will certainly attend. Will get this
Thank you, Mr. Ravi. Thank you. Thank you, Mr. Mahant, also for your session. So thank you very much once again.
My pleasure.
Thank you, participants. I think you can stop recording and stop streaming, Kishore. Thank you. Thank you, Kishore.
Thank you, Robin sir. You can leave. Thank you, Mahan sir. You can also leave.
Thank you.
Thank you, Ravi sir.
Robin sir, can you ask?
I lost Kishore.
Okay, can we ask Aparna madam to have a meeting? Now
Yes.
itself, and we can close with the final quiz also and the discussion.
Okay. Yeah, thank you.
Why we have to wait for long Monday?
I lost Kishore anyway.